Okay, so now we're diving into section 5.3, which deals with rational functions. So remember, rational is just a fancy word for fraction. You can write it in fraction form. Okay, so remember, rational just means you can write it in fraction form. Fraction form. Okay, all right. So in this particular section, though, we want to, using the rational functions, we want to derive three things. One is finding the vertical asymptote, the second is horizontal asymptote, and the third oblique asymptotes. So remember, vertical asymptotes um, deal with the equation x equals a number, right? So any number you give, right, that will give you if it's equal to x, that will be a vertical asymptote or represents a vertical asymptote. For horizontal asymptote, it is going to be y equals a number, right? So it's just going to be a horizontal line coming across, okay? And then an oblique asymptote is slant. It's another form of that, or another way to say that it's slanted. Slanted. Okay. So if you have a oblique or slanted asymptote, it might go through the origin, okay, something like this. And then your graph, you know, will be drawn close to it. So remember, an asymptote means it's like I call it an electric fence. You can't touch it, you can't cross it because you get electrocuted. Okay. So these graphs, okay, wherever they may be, this might be going, this direction. Oops. Okay. All right. And this one might be going like this. Right? So they get really, really close to the horizontal or to the asymptote, all right? But again, never touches it or never crosses it. Okay, that's what the asymptote does, all right? It just kind of guides them to wherever that graph needs to go to, okay? But again, never crosses it and never touches it. Okay, so first let's go ahead and talk about or figure out how do we find the vertical asymptote, okay? So VA. Okay. So to find the vertical asymptote, you want to focus on the denominator. Focus on the denominator. Okay. So it doesn't really matter because we're not going into depth with this. Doesn't matter what's on the top or things like that. Okay. All we care about is right now is the denominator. Okay. So let's say we have r of x is equal to 1 over x squared minus 4. Okay. All right. So again, if I want to find the vertical asymptotes, I focus on the denominator. Say, okay. So what does that mean? I'm going to take the denominator, pull it out, and I'm going to set that equal to 0. Okay. And then I solve. All right. So I add 4 to both sides. That will give me x squared equals 4. Then I take the square root on both sides. That gives me x is equal to plus or minus 2. Okay. So what does this mean? Well, this means that, um, well, two things. One is if I plug in these values in there, it's going to make the denominator 0. And that's what I'm trying to do. Okay. Is that how, how can I make the denominator 0? Is that possible? If so, what are those numbers to make the denominator 0? Okay. And I found them, which is plus and minus 2. Okay, the second part of this is that this indicates that we do have a vertical asymptote. Okay, so there's a part in the graph, there might be a hole, there might be an asymptote or something that's causing this whole function to collapse at a certain point. In this case, at these particular values. Okay, so the answer to this would be yes, we do have vertical asymptote and they are between x, they are plus and minus 2. Okay, that's all be right there. All right. So let's try another one. So let's say we have Rx is equal to 2x over x squared minus 8x plus 16. Okay. So again, I don't care what's on the top. All I care about right now is in the denominator because I'm just focused on my vertical asymptote. Can I make the denominator 0? Okay. Right. So how do I do that? So again, I take this out, right? I pull out the denominator and I set it equal to 0. Okay. And then I solve. So in this case, I need to factor this. So I have x minus 4 times x minus 4 equals 0. Since the factors are the same, I just need to do it once. All right, so x minus 4 equals 0. So x is equal to 4. Again, what does that mean? That means we have a vertical asymptote at x equals 4. Okay, so this chart here is going to tell us how do we find the horizontal or oblique asymptote. All right. So right now it looks overwhelming. There's a lot of information here. All right. But we're just going to pick out the essentials. So here you have R of X and you have a rational function. Okay. So P of X over Q of X. Again, that's just a fancy way of saying I can write it in fraction form. Right. In which the degree of the numerator is N and the degree of the denominator is M. Okay. So let's look at the first one. It says if n is less than m, the degree of the numerator is less than the degree of the denominator, then r is a proper rational function and the graph of r will have a horizontal asymptote at y is equal to 0 for the x-axis. Okay, so what does that mean? Well, let's say we have x squared divided by x to the third. Okay, x squared over x to the third. So notice that the numerator n, right? The numerator n is less than the denominator power, right? Right? So 2 is less than 3. So if 2 is less than 3, what does that say? It says that we do have a horizontal asymptote at y is equal to 0. And that's all we write, right? We look at the leading power. It tells us, hey, this is less than the denominator. So my conclusion is I have a horizontal asymptote, okay, at y is equal to 0. Okay. All right. So check. Okay. So now let's look at the next part. It says if n is greater than or equal to m, the degree of the numerator is greater than or equal to the degree of the denominator, then r is improper. Here, long division is used. Okay, we're not going to do long division yet, but let's look at these A, B, C parts. The first part, or 2A, it says if they're equal, if the powers are equal, if n is equal to m, okay, the quotient obtained will be the line y is equal to an over bm, which is a horizontal asymptote. Okay, what does that say? So let's say we have 8x to the fourth divided by 2x to the fourth. Okay, so in this case, n is equal to m, right? 4 is equal to 4. So it's saying, okay, if we have this combination where the numerator and the denominator have the same power, then all we need to do is reduce this, or in this case, cancel out the x to the fourth, and we'll have 8 over 2, which is equal to 4. And that means then our horizontal asymptote will be at y is equal to 4. That's it. That's the Cliff's version of this, what this is saying. Okay? And that's all we do on that part. Okay? So that's check. All right. The second one I'm going to skip for right now. Let's go to the third one. It says if n is greater than or equal to n plus 2, the degree of the numerator is 2 or more greater than the degree of the denominator. The quotient obtained is a polynomial degree 2 or higher, and R has neither a horizontal nor an oblique asymptote. Okay? So if it has this condition, it says that, hey, we don't have a horizontal or an oblique asymptote. Okay? All right, so what does that mean? So let's say we have x raised to the sixth power divided by x to the fourth power. Okay? So notice that n is greater than or equal to m by 2. Okay? So 6 is greater than or equal to 4 plus 2. Okay? So again, if we have this combination, okay, that means then our conclusion is we have no horizontal asymptote and we have no oblique asymptote. Okay. All right. So if the power here is two or more than the one in the numerator, then we have this situation. Okay. So questions so far. Okay, so again, you'll have this chart on your exam. Okay, so you don't have to memorize it. So what we're doing here is we're just looking, in this case, we're just trying to find the horizontal or oblique asymptote. So what we're doing is we're just looking at the leading terms of the function, okay, and comparing them. So in this case, I'm going to compare this term to this term, okay? Particularly, I'm looking in the power. So this one is x to the first power, right? This is x to the first power, and this is x to the second power. So in here, in this case, we have the situation where 1 is less than 2. So the numerator is less than the denominator, m. Okay, so I look at my chart, and that's going to be the first one there. N is less than m. I know it's kind of small here, but I don't have a lot of space here. So, well, let's see here. Let me pause this for a second. Okay, so we have here is n is less than m, right? Because we have 1 is less than 2, or n is less than m, right? Because again, it's the numerator divided by the denominator, or n divided by m. Okay, so since we have this situation, then our answer is just going to be that we have a horizontal asymptote, and it's y equals 0. Okay, so in this case, we have a horizontal asymptote, and y is equal to 0. Okay, all right. Do you want do you want to try the next one there? Okay, try the next one.
You're muted. We can't hear you.
Okay, sorry if I was muted. Okay, so again, what we're looking at are the leading terms. So that's all we care about, particularly the powers. The powers are, what are they? They're the same, correct? So if we look at our chart, if the powers are the same, then we use this one. N is equal to m, right? 2 is equal to 2. N is equal to m. So if that's the case, then all we need to do is divide those terms. Okay, that's what it's saying. The line y is equal to an over bm is a horizontal asymptote. So that means then I have y is equal to 8x squared divided by 4x squared. The x squares are going to cancel, and I'm left with 8 over 2, sorry, 8 over 4, which is equal to 2. Okay? So in this case, I have a horizontal asymptote at y is equal to 2. Okay? All right. And then the last one here, yeah, we're not dividing the whole thing. All we're worrying about is the leading terms. I don't care about the rest. Okay? So the last one here, it's a different color. All right? Again, we're going to focus on the 3x to the fifth and 7x to the third. Okay? So what do we know? Well, it's going to be what? Part C, right? When it says n is greater than or equal to n plus 2. 5, right, is bigger than 3, right? So by what? By 2 or more, right? This is saying by 2 or more. So that means we have to apply this one. So if we have the situation where the power is bigger in the numerator is bigger than the denominator by 2 or more, then it says we neither have a horizontal nor an oblique asymptote. Okay? So in this case, then we say we don't have no horizontal asymptote and or no oblique asymptote. Okay? If we have the situation. And that's all we write there.